When you look at data, you want to be able to tell what shape it is. If it's generally a straight line, we call it linear, and if it curves like a parabola, we call it quadratic. So the shape is what helps me determine what the best model is. And when we use this fancy word regression, think of it this way. It's a mathematical model of data. So when we get a data, it's basically like saying, hey, give me the equation that goes through those points. On the calculator, this is what we're going to see. It's going to give us these big old huge patterns, and we're going to have to train ourselves how to write them. They will always give you the pattern in the top row, like mx plus b, and then you're just pulling the numbers down into the equation. So linear is y equals mx plus b. They use a and b. Quadratic, just like we're used to seeing, ax squared plus bx plus c. Little things, like if b is negative, you make sure it's negative in your equation. And we're going to explore something called an R value today. It will show you how to turn that on the calculator. If you have an R value of 1, that's perfect. It means 100% of your data is hit by whatever equation you've come up with. This would be, in the high 90s, so still very good data. If you look at how to turn that on, it's going to look different in every equation. This is what we're going to find. Know this part of the notes is here, so you're going to go to Stat Calc. It's a second menu in there. And then you're going to have to tell it where to store that equation. And this is important to know. If you have an older operating system on your calculator, your screen's going to look like this. It's the same exact thing as the newer screens. When they do the same function, hit Stat Calc, they're going to have to come down here and highlight the word calculate, and they're going to have to say, hey, where would you like to store that regression equation? Y1. So this series of steps, variables, y variables, function y1, is just going to look different on the calculators, but it's the same exact skill. And in general, if it goes up, you'll have a positive R value. If it goes down, you'll have a negative R value. And if your data is all over the place, you're not going to have a real strong correlation. So how do we do this thing with R values? This is important to know. You might not know that you have a catalog on your calculator, so I want everyone to go look down on the lower left side near where it says the 0 key, and there's your catalog. So if you go to catalog, it is an alphabetical listing of everything in there. Highlights of fun stuff to come in math. You want to go down to where it says diagnostics on, and you want to make sure you click it until it says the word done. Don't just highlight it, make sure you click it the second time and see the word done. So when you see the word done, you're good. Now, here's our data. We have a container, a bucket filled with water. Water is draining from the hole near the bottom, and this is the level of water. So it starts off with a lot of water, and as time goes on, in seconds, the water goes out. So we're trying to figure out mathematically if it's better to say this is linear or quadratic. These are our two choices today. When I look at the data in the calculator, I am going to go back to my stat edit area. My list 1 is going to be my time. My list 2 is going to be my centimeters of water that are in that bucket. And I'm going to have to go through those techniques of hit the stat, calculate, and the first thing I want to do is I want to try linear. So I'm going to hit my linear regression. And I'm just going to say, hey, calculator, go ahead and do it. And there's my first equation. I want to try something different. I want to try, this time, quadratic, stat, calculate, and right below linear is quadratic. Quadrag is the shorthand for it. And it's going to come up with this for an equation. And I'm going to have to make a judgment. So I'm trying today just linear and quadratic. These are the two screens that I got. And the reason that I want to end up picking quadratic here is by looking at the R values. It's a stronger R value for the quadratic. Now, notice there's an R and an R squared here, but no R here. Quadratic, because it has both positive and negative spaces, will only have an R squared value. So you can compare those R squareds just to get a general idea of which data is closer. We are comparing that 0.999 number to 0.951, and this guy's better. So I'm picking quadratic based on the stronger R squared value. On this second example, I want to take a look at different data. We're looking at selling prices of some homes, and so we go back to my stat menu. I need to enter in my 0 through 5. And if you have data in, remind yourself the fast way to clean it all out so you don't have to delete individually. Put the cursor up on the list name, hit clear, and then enter. So here I have 154.5, 166.4, I won't read them all to you. Data entry is so much fun. And the last one, 273.5. I always think, hey, why don't you slow down and go back and look at it? So this is what happens most of the time. We enter it very quickly. If that happens, just go back. Take a moment to look at your actual paper and see if maybe you did make an error in here. If you have some number that's way out of whack, like, I think there's an extra 2 in there, you'll catch yourself this way, and you just type over whatever's in there. Also notice that I had typed in a 0.0, it just won't show up here. So that's totally okay, and that's just to be expected. So I want to make a scatter plot of this data. So a reminder, we go to stat plot on, and then zoom 9, where we set the window to whatever data we have. So this data kind of goes up, and I'm not sure if it's going to be linear or quadratic. It's got a slight curve to it, but I don't know. So this is going to be the process of going through stat calc 2 times, comparing linear, which is going to be option 4 here, and this time I'm going to use my pasting ability. So variables, y variables, function y1. I'm going to right now have the calculator do the equation, and I'm looking at a pretty high R values. That's pretty good. And what it did is it pasted it right here. So right now I'm looking at the linear equation go through the data, and it kind of misses some of them. So I'm going to try the quadratic here. I'm going to go stat, calc. I'm going to pick quadratic, which is option 5. I'm going to say, hey, you know what? Go to variables, vars, y vars on the right, function. This time, I'm going to be savvy. I'm going to paste that one in y2. And when I do the actual work, the calculator has taken all those values with the decimals, pasted it into y2 on the calculator. So now when I graph it, the first one is my linear. The second one is my quadratic. Oh, look at that. It's better. It's not perfect, and this is life. It's not going to be perfect most of the time, but it does look like it goes through more values. And if you look back on this screen, that was a higher R value than we got before. So I'm going to make the choice to write this equation. Notice I have 3.380, 6.155, 155.625. So this is what I'm going to write here. I'm going to choose my quadratic. I'm going to record those numbers down. 3 decimal places is just your rule of thumb unless you hear otherwise. And make sure you include the x's in the pattern. So the calculator will always give you the pattern, and you're writing it down to 3 decimal places. There's my pattern written out. They want to know what the pattern is going to be for year 8, and this is just a really strong reminder that once that equation is in there, I'm going to go to my table. My quadratic is y2, and I'm going to scroll down to year 8 and see what my house price is. Remember, this is in thousands, so my house price is going to be pulled from the table, $421,210. Again, came from that location right there. So 210. If you wanted to say, actually I should probably say 211 there. Sorry about that. So there's your scatter plot. There's my choice of picking them out. And if you don't know this, one little side note, if you have a lot of things in your y equals and you don't want to see them all at once, if you put the cursor over it and hit enter so that it's unhighlighted, it will only graph the equations that are highlighted. So there's your fun fact for the day on a graphing calculator. For our final problem, we're looking at kind of interesting data. It says here in the table, we're looking at the relationship between the number of students in a math class and the average grade for each class. So we want to come up with an equation, we want to find the correlation coefficient, and we want to describe it and see if it's good or mediocre. In this case, I'm going to go, hopefully, to my calculator. There it is. And I'm going to check that I have my data in my stat edit. So this is the data for class size based on grade. So I have 16 through 32 in list 1, 81.2 down to 77.7 in list 2. I'm going to make sure my stat plot is turned on by making sure the word on is highlighted. Go to zoom 9. That's how we get the window to match our data. And here's what we see. And in general, the bigger the class, the lower the grades, with a sweet spot right around 24 students. So fun fact, I think that is the best class size. So what I'm looking at now is trying to decide, stat calc, is this equation better linear? So I'll take a look at that equation. Remember, variables, y variables, function y1. I'll paste that in and compare the linear, which, it's missing a lot of data up there, to now the quadratic. So what I'm looking at is stat, calculate. Quadratic is option 5. I'm going to paste that variables, y variables, function, and y2. That way I can have both equations in there at once. Please remember, people with the newer calculators, this is where you store your regression equation, and you have to hit the word calculate where I hit enter. When I look at this graph, that's first one's my linear, missed a lot of dots. Second one's trying to go through some more. It kind of shows that trend a little bit better. It's by comparing the R values that I'm going to see. If you remember what it was on the home screen, this wasn't really great, but it's kind of as good as we're going to get. But when I look at my quadratic equation here, I'm going to have to do some rounding when I write it. 0.022, as I look at this, 0.826, 73.316 is what we'll end up writing, because this is my better R value. None of them are great. And if it frustrates you that you have all the different R squareds, you always have the right to go through and do square root. So if I did the square root of that 0.6326751, having trouble writing that, I'm going to get like 0.795. That's my best case for an R value. So my R squared and my R, I'll take either one on this one. I have 0.795 for my R value, and the R squared value that came out that was better than linear was this number here, 0.633. I guess I'll write down. And we'll be clear if you need the R squared or R. And when I look at the actual equation that they're looking for, you have to make sure you're writing it down with the correct rounding. So I'll write it down. 0.022 is the coefficient on x squared, that's your A. 0.827 is the coefficient on x, and 73.316. And again, that's coming from the equation in the calculator with your rounding going in. But is it strong? Yeah, so. So there's your scatter plot, quadratic, better, but neither one's great. It's just messy data. Happy regression finding.